Hey guys, in this video I'm going to walk through this Leetcode number 53, maximum subarray. So we are given an integer array nums and find the contiguous subarray containing at least one number, which has the largest sum, and we need to return its sum. So we don't need to return the subarray itself, we just need to return the sum. So this makes the problem a bit easier, and subarrays are contiguous of part of the array. So basically, it's a continuous, like 1, 3, -3 and 4. So this will be a subarray, and -1, 2, and 1 that's a subarray, and also just one number itself, it can be a subarray as well. And in this case, as we can see, 4, -1, 2, and 1, that's a subarray that has the largest sum. So basically, a brute force approach will be iterating all the possible combinations. So for example, the first number can start from here and end from here. That's one subarray, and starting from here and end from here. So there's another subarray, all start from here and end. So as you can probably guess, this takes a lot of runtime, and the time complexity is going to be big over n squared, and so this is going to be very slow. And we will implement the approach using a linear runtime, so that's a lot faster. And this question was asked by all these big names, so especially Amazon and LinkedIn, Apple, Microsoft, etc. So it's one of the most popular question on Leetcode, as you can see that how many likes on it. So the way that I would go about for this question would be when I scan through the subarray. For example, if I started from here and end from here, so that one subarray will be the sum will be +4, right? And when I look at this number already, number 4, when I start from here, I wouldn't include all the number before that, because if I include that number, that will decrease my running the cumulative sum, right? So that's why if I come across the prior numbers, I would not include them, right? If I started from here, I wouldn't include any number before that. If I include this guy, it will be 3 lower, right? This one will be 2 lower. Even I include everything, it will be 0. So there's no gain for this one. For the 4, that is include anything before that. So that means I will start it from over, just from the current position onward. And if I was here, I start from here, I wouldn't include that number because it's -5, that's it's a lot lower than 0, right? If I start from here just including itself, that will be 0. And that's exactly how we will go about this problem. So first, we handle one edge case where if the length of the nums equal to 1, so we automatically return the number itself. And we have a running cumulative sum that's 0, and we have an answer that we will return at the end. So we will initiate the answer will be -infinity, and for all the numbers that we are scanning through, if the prior, let's say if we are here right now, if all the prior running cumulative sum is negative, we won't include them, because I could just start in from the current position, and that will give me a current running sum will be 0. After that, I just add the current number to it, and then compare that to the prior answer that is I've been comparing against. So I just take a maximum of the running maximum, and then return the answer at the end. So the code is pretty simple. Let's run that. Yeah, it's pretty efficient, as you can see. And this is the time complexity is big O over n, and for space complexity is big O of 1 actually. We only need this variable, also need this variable, and that's about it. Yeah, that's my simple solution to this problem. I hope you like it. If you do, please like this video and consider subscribe to the channel. That will be a huge encouragement to me to make future videos looks like this. Thank you so much for watching, and I will see you in the next video.